This is student peer teach problem number 3. This one's a little bit different. It's a coordinate proof. You've seen these before. Not terribly complicated. First, we're given a quadrilateral with these points. Get your classmates always to first label these coordinate points. So G is at 0, 7. H is at 6, 3. I is at 4, -3. And J is going to be at -2, 1. Our goal is to somehow get these two angles to be congruent. HGJ, so physically trace H, GJ, that's the elbow right there, is congruent to JIH. Get your classmates to draw it. JIH. Okay, now look, when we're dealing with a coordinate plane, there's only 3 things we get to work with. We get to work with the distance equation, slope equation, and the midpoint equation. Get your classmates to say that. Distance gives us length. Slope will give us parallel or perpendicular. And midpoint will show things have been bisected. Now, there is no direct way that any one of these 3 equations could show these angles congruent. No, there's no direct way. So we have to do it indirectly. And the way we're going to do it indirectly is we have to prove if the triangles are congruent, then the parts are congruent. So keep in mind, if we can prove that the whole triangle is congruent to another whole triangle, then we can say that the parts of the triangles are congruent by CP/CTC. Okay, so if one whole triangle is congruent to the other one, then they're congruent by CP/CTC. So our goal is to ask ourselves, how can we get the triangles equal? There's side, 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 angle, side, side, angle, or angle, angle, side. Only 2 of these really work. Distance equation will show us length. That'll help us to find sides. Slope equation will give us parallel, which indirectly can give us angles equal if we use armpits of the Z. Let's look at what we already have. We already have one reflexive side. Now, if we're able to show the other pairs of sides are congruent in length, then we're going to be able to get the triangles congruent by side, side, side. That's what we're going to go for. So first we're going to find GH and JI. Make a template. Get your classmates to make a template. Watch them make templates so that you know that they can do this on their own. Here's a template. Ready? We're going to go x minus x. So 0 minus 6. 7 minus 3. The other one, -2 minus 4. And 1 minus -3. This is going to be -6 squared plus 4 squared. And our GH is √52. Let's do this one. This is -6 squared. That's double negative root positive 4 squared. Lo and behold, that's the same thing. Now let's go the other direction. Now we're going to go G to J. Again, start with the template. And we're going to go IH. x minus x this way, that's going to be -2 and 0. And y minus y, 1 and 7. That's going to be 4 and 6. -3, -3. Let's do our math. This is -2 squared. That's going to be -6 squared. That's 4 plus 36. We're going to get it right here. GH is the square root of 40. This one, that's going to be -2 squared plus -3 minus 3, that's -6 squared. Once again, that's 4 plus 36. This is also square root of 40. Lo and behold, they are the same. Now, once again, look at what we're trying to do. We're trying to make the whole triangles equal, which we just did by side, side, side. And if the triangles are equal, the parts are equal. Okay, ready? Now we just need to summarize this. This is easier to write out if you start with where you're going. We're going for side, side, side. Step number 1 is the fact that, let's get our freebie, that's the easiest. We know that JH is congruent to JH. Why do we know that? Because it's reflexive. That's our first side. Then we have these two sides, JH and JI. GH is congruent to JI because both root 52 by distance equation. That's our second side. Let's get the third pair of sides. GJ is congruent to IH because both root 40 by distance equation. Therefore, those three little dots mean therefore. You'll encounter that in physics. Therefore, we know that the triangles, the triangle GJH, HTJ, and JIH, we're going to use those, as congruent to triangle JIH by side, side, side. Finally, if whole triangles congruent, then parts congruent. So we basically have angle G is congruent to angle I. And that's called corresponding parts of congruent triangles are congruent.